We were talking about models of the atom to help us understand what's going on with the electrons inside the atom. We talked about the Bohr model, and the Bohr model involves the electrons orbiting the nucleus just like the planets orbit the sun. And we said that unfortunately that didn't work for anything but hydrogen. So the Bohr model was replaced by the quantum mechanical model in the early 20th century. And this is a very revolutionary model because it states that electrons do not act like particles flying through space. And if you've heard anything about Einstein and his theory of relativity, you know that when you take things to an extreme, either extremely large, extremely small, extremely fast, things get kind of weird. So we throw a baseball and we can predict where it's going to go. We throw a marble, which is smaller. We can predict what's going to happen. Physics can give us equations for its trajectory and velocity and all that. When we get smaller and smaller, we come to a point where the particle does not act like a particle anymore. And so electrons do not act in the way that we're familiar with. Thank you. Yes, I should put the projector on the screen. So in this quantum mechanical model, instead of orbits, we have orbitals. And it's just a little difference in the word, just 2 extra letters at the end. And so it's very easy to confuse orbits and orbitals, but they are not at all the same thing. They're very, very different. So don't let the similarity in the words confuse you. Orbitals are probability maps. So a statistical distribution of where an electron is likely to be found. It doesn't tell us where the electron will be found, but where you could most likely find an electron. So we can compare baseballs and electrons. This is appropriate because it's spring. I don't know, and Reedley Little League opening day was on Saturday, and so now there's lots and lots of baseball going on. When a pitcher throws a baseball, it is predictable where the baseball is going to go. He can do funny things to it. He can make the trajectory do some funny things. He can throw a curveball. He can make it drop suddenly or do a change-up in how he spins the ball and how he releases it. But it is predictable. If he throws the ball in the same way every time, it will go the same place every time. If you have a pitching machine and you have it set up, it will throw that ball in the same place every time. It's predictable. But electrons are not predictable. If you had a pitching machine for electrons and pitched those electrons in exactly the same way every time, they'd go somewhere different every time. And this is not what we deal with in everyday life, but this is something that happens when you get things that are so small. So electrons, in some ways, behave like photons, or particles of light. Light is a wave, but it also behaves like a particle. Electrons are particles, but they also behave like waves. So if we pitched an electron, and you could imagine maybe there's a screen here, and each of these white dots is a hole where the electron went through. And you pitched the electron a number of times, you would end up with this sort of distribution. And most frequently it would be towards the center of this, and less frequently out here, but sometimes it might even be out here. It's not going to go the same place every time. So an orbit from the Bohr model is a predictable circular path that the electron goes in, and we can predict its energy and its velocity and all kinds of great stuff, and we felt really comfortable with that. But unfortunately, that's not what electrons do. And this is part of why, which one was it? I read you those quotes at the beginning of the chapter. The one guy, can't remember his name now, he said, "I don't like it, I wish I'd never had anything to do with it," the quantum mechanical model. An orbital is just a probability map. It's completely unpredictable. We cannot predict where an electron is.